Hey fellas. So it was a couple days ago. Sam over on YouTube. Check out his channel. I think it's CNC for XR7. Pretty cool stuff. Super legit. Home shop machine hobbyist kind of thing. Makes some really nice parts and does lots of precision mathy stuff. Yeah, I think I see a couple other, usual suspects. Say hi to Chris and I think Gary, CNC zoners. I might have even seen a Mr. Ruststuff dip by for a second. So enough rambling. We'll start with the motor, I guess. This will just be sort of like a belt drive spindle, my take on it. So this is the motor. It's a Leeson D80. 750 kilowatt, 1 horse. So, Sam, you were talking about your motor. What I did for my Leeson, and they should be the same, I would think. I made a steel hub that then I broached for the a key, and as you know, the end of that motor is tapped. So there was also made a washer and it threads into the end of the motor. The hub was actually, it's keyed, but it was also it's a shrink fit, so it's like double duty. But it makes it pretty sweet to you can quickly you just pull the pulley off the hub, so it's a sort of a fun little package. So yeah, I think that sums it up. With that, some people talking about maybe lots of people don't have like broach sets and stuff. I know they can be sort of handy. I don't recall what size it actually is, but like, let's see, push broaches. I think you'll have to remind me what the key size is. But I think I, for some reason, had a broach, but I didn't have a bushing. So I made a bushing and broached it in the hydraulic press. But sometimes it's easier to find non-metric broaches. And you could also try to do a step broach if you'd like. So it would be like a metric key on one end and SAE on the other, whatever you call it. Sidetrack. Broaches, hubs, motors, pulleys. So here is your run-of-the-mill Grizzly spindle. Similar setup to like a larger machine. Same idea at least. But looking at your Sam, it might be a little different. So hopefully this will clarify, because it seems like I don't know, Chris and some people are like, you either want to drive it by the spines or you don't, or some like run out issues and vibration and like, so I'll tell you, or I'll show you what I got, I guess. So on the stock Grizzly, this, the end of that quill spline is threaded for some weird like 20 by something metric size. Anyways, these threads on here, just like lots of the stuff on the machine, are like non-critical, tolerances. They're just wide open. You get what you get. So this thing was obviously done with like a tap, or not a tap, but like a die, and it was crooked, like literally threaded crooked on the end of the shaft. So to remedy that, because it's important for my drawbar top hat, because this is what lightly seats the pulley on the barrel. So we'll talk about that soon. But the threads on the end of there were horrible. So that's important, because that hat needs to seat down perfectly square on top of this pulley right here. So it was rethreaded single pointed on a lathe, and I think that's really important, because those need to be they need to be dialed in. So it was rethreaded. I don't recall the exact thread, but it's a SAE thread, and it just so happens it's like the only thread that will work like with the existing metric miter diameter and still give you like some thread engagement. So it actually turned out really freaking sweet. Like, well, it did. We'll show that in a second. So here is the, I call it a top hat, steel, and you can see this was also single point threaded on the lathe, and you can see it's relieved in there because there's actually like a shoulder on there, and we need to clear that. So let me slip the spindle in, and actually we'll do the indicator first, I guess. Here is the quill barrel. My pulley references off of this bearing surface right here. This is the same surface that the bearing references off of. I think I saw someone, they made a pulley and then they shoved the pulley thing inside of here. Like, well, this thing has, like, on my machine, it's got 5 thousandths run out. I mean, that'd be a problem. So yeah, you need to reference off of this outside, or at least that's what I did. So first we will we'll measure the, or I'll put the indicator on this inner bore diameter. Let me grab the camera. Let's see here. There we are. Okay. Let me tighten this thing up a little bit. Come on, you glare. Ah, perfect. Let me put the camera down so it's not going to be shaky. Dead wood. So yeah, it's pretty cool. Doing the YouTube thing and like the little, you know, YouTube machiney community, like, you know, critiquing and, you know, running ideas back and forth. It's pretty fun. I like it. Okay. That's better. Nice. Thank you, Mr. Gimbal. I think that's loaded up. Yeah. So this is a 1/2 thousandths indicator. I think if I got a 1/10 indicator, it would just like muddy, you know, too much resolution, I think. So this is on the idea there. There's 5 thou. So yeah, I mean, it sort of depends on where you put it, but 5 thousandths of an inch of run out on a spindle. I mean, it doesn't matter if it's on like a $5, you know, CNC machine or like a $10 CNC machine. I think that that's probably not a good idea, and that's maybe what Chris is talking about. Is that yeah, I would agree that would induce some vibration for sure. So. Let's look at this outside reference, which just so happens to be the same reference of the bearing. And these are just Koyo, I mean, replacement bearings. But I've had this barrel, I put it in the lathe. And you can see there's no gears left on it. And yeah, it's let's take a look at it. So get that bugger tight. What do you mean it's not? Oh, there we are. Nice. So I think I get like maybe half thousandths to run out. Let's get you colors here. Dagwood. Considerably less, and it really didn't do much to the surface. So if I were to pick a surface, it would be this one. But okay, let's spin it. So you can see, let's see, I think these little holes here, these were where the little, call it a reluctor ring, you know, something like that. And that's the little, you know, dip right there. But this, this beats the inside of the spindle any day. So that is what my front pulley references off of. All right, I'll put the spindle in, and then we'll pull up closer and we can look at the pulley and how it references with the 3 pins. So this just goes in like a regular Chinese spindle. It's tight. Okay. Let me tilt it up. Okay. Spindle, pulley. This thing is it's a really tight fit. So these are the couple different sets of pins that I've made up. You could probably tell the look, how they look different. These are actually these are drill rod, the size, and then these are some just some like round stock, and these fit a little looser. It makes it a lot easier to take it apart and reassemble it, just due to the little bit looser fit. So I think what I'm going to do before I put this together for the final time is let me slip some of these pins in here. Drill and tap the ends of my 3 pins, so it's a little easier to remove them. You know, I can thread in like a socket head cap screw and sort of you know, slide hammer style it out of there. So that should work. So I'll take the pins out. So yeah, 3 pins, and then this is my reference surface. It's a bee's knees to get on here. You want to get these. Darn it. And then this. So that snaps on there with some authority, and then your pins, you got to get it sort of aligned up. And I also have this sort of keyed because when I put it together the first time, it fit nicely, so I was like, I'll mark it. But so yeah, those go in there. Tap, tap, tap-a-roo. And this is where like the importance of like these 2 flat mating surfaces for me came in. So this threads on here rather nicely. I'll give you that ooh, check my threads out spin. Oh, ooh, ah, ooh. So really all this thing is doing is holding this pulley snug against that flat true reference surface. And then of course, a cool drawbar goes in there, and yeah, that's my take on it. I've when we first built it, ran it for a while, and I had the Hitachi drive cranked at 120 hertz. I think it was a 400, but I don't know if the Leeson's down with that. But yeah, it's smooth, and it doesn't tell me right away that anything is not jiving. So I'm sure we'll find out when we find out. But yeah, I think the only downside, and it's more something to keep into consideration, especially for people with gorilla hands. So when you tighten this down, you think about what you're doing. You got tapered roller bearings here with the preload set, so you're basically like pushing a bunch of, trying to pull these two bearings together, which is probably not a good thing. So that would probably not be good if you had to, put 450 foot-pounds on this, but you don't. I actually have a brass set screw just for, copaceticness. Not that it needs it, but so yeah, you just snug this up. You're just holding that pulley in place, and then your machine might be a little different, but then I throw on top of here 4,000 pounds of Belleville washers, so I'm not too worried about it coming undone. So yeah, that's my take on a Chinese spindle. I'll tell you one thing though. Once this machine's done, that's the one of the things that I'm definitely going to make my own spindle. There's just a lot easier ways to do it, and the easiest way to do it is to throw the whole spindle away. And like a R8 taper is an easy peasy one to machine and then grind on the tool post grinder. So these, the spindle pulley and the driver pulley were they're homemaders, and I've seen some people like make like pulleys and stuff and have like lots and lots of run out, and like you should be able to make a pulley, whether it be on like a mandrel or like a spud, in a 3-jaw chuck with two operations with I'll say less than a half a thousandths of run out. So yeah, the spud or the expanding mandrel is the key, especially if you don't want to fudge around with a 4-jaw, because there's no sense. Mandrel. So I think on this, let's see if we can find it. That's too small. Maybe this guy. So yeah, expanding mandrels are super killer for doing lathe work. Pulley kind of stuff where you want to try to pick up another reference, do it between centers. Drive it with a lathe dog. And then for this, if you wanted to modify like an existing like pulley, like that one's been, you just take a piece of round bar, you put her on your 3-jaw chuck, and then just turn your reference surface on that 0, bolt your pulley onto your spud, and then do your second op, like whatever you got, but just make sure to get that center hole dialed in. Like that's what you care about, I would. And then what is that thing? So yeah, bore grooves, and this little triangle pattern was I think I used, yeah, this is just a little indexing fixture that does your common angles, and yeah, it worked great. It was a little fishy trying to figure out like what the Chinese had going on there, but yeah, it's definitely a lot of work, but we'll see. So I think Chris was talking about the, or Sam asked Chris about the, you know, like common drilling RPMs and like what he finds that he uses, and like that was a question I was interested in too, because I see lots of people go with, there's a 4-pole motor that's like a 34 something. It's a 2-pole. So this is like a 17 something. Anyways, yeah, my dad's friend owns a big like industrial electric motor rebuilding shop, and the Tachi drive is rated to 400 hertz, and he was like, we asked him like, oh, what do you think about, you know, spinning a 2-pole to 120 hertz, you know, twice the nameplate rating, and he says, go for it. There's nothing different, you know, they don't make a 2-pole any different than a 4-pole, and just think of a 2-pole like a 4-pole that you're just spinning a little faster. So that's what we're gonna go with on that. That puts me right a little over like 5,500 at a comfortable like 110 hertz or something. So yeah, it's either that or you 4-pole, but then you got to underdrive the thing, and you know, to get to like, you know, 1,000 RPM, it seems like you would have to be doing it like 0 hertz, but I guess that is negligible if you have some sort of vector drive. But I mean, the motors are cheap. They're like 150 bucks. So worst comes to worst, you could just throw a 4-pole equivalent on there. But I'm not sure. I'm tired. All right, so I guess I'll try to sum it up in the best way I sort of understand it, I guess. And which I would completely agree with. One would not want to just put a pulley on there and, you know, tighten a belt. That makes sense. I wouldn't reference anything off of this inner bore. So I think back in the treadmill motor timing belt days, people would drive their they would just literally use these stock little screws from the that ring that used to go there and drive away. So yeah, I guess mine is just a little different version than that, because it drives the quill, but, and I think the important part is that these 2 top bearings are the thing that are taking the load from the belt tension that way. So there's always more than one way to skin a cat, and everyone's, you know, I think got to sometimes sort of learn for themselves, you know, like there's something really to be said about figuring shit out. And like, I know people are like, oh, you know, save me so much time, but like, this is fun for me. The Precision Matthews 727, I think it's called. I noticed that the spindle and this barrel thing are considerably different. It seems like that particular machine has some sort of gearbox in it with maybe some sort of like splashy oil lubrication, because I noticed some like funny like seals and some other stuff that are definitely not on this. So I think you might be onto something by like flipping that quill barrel, and yeah, then maybe drive the quill barrel. But you definitely, like, I think the most important part of this whole thing is that how this references on here and how this all fits together. I just wanted to give a little, you know, insight into what I'm gonna try. So I'm sure I inadvertently missed some point that I'm sure when I'm putting this little clip together, I'll be like, damn it, I wish I filmed that. So yeah, thanks Sam, Chris, all y'all out there. Hope to hear from you, and yeah, dude, it's looking pretty good. I'm gonna actually shoot another little video here on the progress on that. So yeah, check it out, and thumbs up if you dig, thumbs down if you don't.